Hi Bart, this is just a recap of all the things we did yesterday. Just calculating the areas of the different shapes that we looked at. So the first one was the triangle. If you remember that nearly every shape is essentially just a rectangle in disguise, and the triangle, no exception to that. So we can see that it's essentially half a rectangle. So I'll finish that rectangle off by drawing a horizontal line. Oops, that's the wrong one. Let me try another one. There we go. And then drawing a vertical line, you can see that it makes a rectangle, so the area of it must be half of the rectangle. So since we find the area of a rectangle by just doing the base times the height, or whenever we just multiply two numbers together, it gives us a rectangle, then we need to halve it. So the area of a triangle is going to be half the base times the height. So half times base times height. Or half a rectangle. Okay, so that's, as long as we know the height and we know the base, we can find the area. Moving on to a circle, before we talked about the area of it, we talked about the circumference. So do you remember that I said that the most important measure that a circle uses is its radius, this thing that goes out from the centre to the edge. It radiates out like a radiator. So it's called a radius. It goes going from the centre out to the edge. You said about diameter. Diameter is twice that. Diameter literally means twice the measure. So the measure it is referring to is the radius. And if we were to pick one up, imagine it was like a flexible piece of string and droop it around, the first one would reach down to there. The radius would reach from that point to that point. And if we keep using that as a measuring stick and then just counting how many radii, or radiuses, whichever way you want to call it, go around the circle, you'll see that that's 1, that's going to make 2, drop another one down, that's 3, drop another one, that's 4, 5, 6, and a bit. Okay, and that bit turns out to be 6.28, so we can fit 6.28 round. So the circumference is 6.28 radii. And as you noticed straight away, you thought, oh, that number sounds like 2 pi. It is. So 2 pi r is the formula for the circumference. And that's why, because we can fit 2 pi radii around the circle. Doesn't matter how big the circle is, if the radius is larger or smaller, the circumference gets larger or smaller along with it, so it's always going to work. So 2 pi times pi r. Okay, looking at the area of a circle, remember I drew you some squares, and I said that phrase that you might ask your mum if she'd heard of it. I bet she has, which is that you can't put a square peg in a round hole. And this is a problem because we use squares to measure area. That's the definition of area, isn't it? Like I said on lesson 1, first thing we learnt. The definition of area is how many squares we can get in and what size. For a circle, because the measure that a circle uses is r, then the size of the squares is going to be r squared. That's our size. Now, if we try and fit them into the circle, you can see that they won't go in. Okay, we can get 4 to completely cover the circle, but we don't want this extra bit on the end. These kind of offcuts, if you like, we chop those off. There's too much area. So 4r squared is too big. So the area of this circle must be less than 4 of those squares. Size r squared. So what is it? Well, it turns out, as we said yesterday, that it's 3.14 squares can fit in. So it's a very unusual number. That's because it's a circular shape and square pegs don't go in round holes. And again, you notice that 3.14 is pi. So the definition of area that we said at the start was how many squares and what the size of the square is. That's exactly what the formula says. It says how many? 3.14, and then it says the size of the square, and the size is r squared. So we can have varying sizes depending on our choice of r, or the circle's choice of r, whatever the circle size is. So for this one, the radius is 10 meters. So that's our r squared, 10 by 10, so it's 100 meters square. So times that by pi, we get 100 pi meters squared, and if we want to do it in decimal form, we just do 3.14 times 100, which is going to multiply, it's going to move the decimal place 2 to the right, so it's 314. I'll put a decimal in there, 0.1 meters squared. So that'll be the area of that very large circle. Okay, so the next shape we looked at was something called a trapezium, which is, like you said, it's a combination of a rectangle and a triangle. And if we wanted to find the area of it, we could find the area of the rectangle, which is going to be 5 times 8. And we could find the area of the triangle, which is going to be 4 times 5, because the distance from there to there is 12. So it must be 4 here to here. And then we then do half of 4 times 5, so that would be 10. So if we did them individually, we'd find that the area of that is 10, and the area of that is 40. So the total area will be 50. However, a cleverer way of doing it is to change the shape into a rectangle. So the way we do that is take what's known as the average height. So if I go halfway down here, then draw a line across to there, and then join it up. What we effectively do, the trick of it, is to move this area here into that spot there. And when we do that, we end up with a rectangle shape. And to find the area of a rectangle is very easy, just the base times the height, or width times the height. So the width is 5, and the height now is halfway between 8 and 12, and that's 10, isn't it? That's the average height. So 5 times 10 is 50, so we get the same answer doing it that way. So whichever way we do it, we're going to get the right answer, but it's better to take the average height. That's more mathematical than to find individual areas of parts, because we're using our brain and going, okay, most shapes are rectangular, so let's just change it into a rectangle. I hope you can't hear my son in the background complaining. He's going out for a walk at the moment, so it's timed that perfectly. Okay, so just back to the circumference. I gave a measure there, 10 meters, so we can figure out what the circumference is of this circle. It's going to be 2 times by pi times by r. So remember, it doesn't matter about the order, so we can do 2 times 10 first, so 20 times by pi, so it's going to be 20 pi meters. And then in decimal form, that's going to be 20 times by 3.14, which is going to be 62.8 meters. So that's how far, if you were to walk around that circle, that's how far you would go. And the area of this circle, the area of this triangle even, is going to be 3 times 5, which is 15. We need to times that by either a half or divide by 2, which is the same thing. And that's 7.5 or 7.5 meters squared. Okay, so I've tried this with a couple of other students now, and they seem to really like it because it gives them a chance to hear it all in a bit more shorter form. So because at the moment you look at the notes and you may recall what we did, and you may not. So here you can watch this as many times as you like, and it should align with the notes and give you a strong reminder of what we did and give you the chance to do the homework. So that homework's calculating the area of different shapes, which I'll send on an email. And let me know what you think of it. If there's anything you want me to add or take out, please let me know. Hopefully you find it useful. I'll see you next week.